moments. This is something we would have already touched upon in GCSE, but we're going to expand upon in the A level. As always, let's start with the definition. A moment is a turning effect on a rigid body. Its direction is clockwise or anti-clockwise. And the formula for a moment is the perpendicular distance from the pivot times by the force. Now, a moment is measured in Newton meters. That's not newtons per meter, it's Newton meters. As the perpendicular distance is measured in meters and the force is in newtons. The way we can think about it is that imagine we have our body, our rigid body, connected to a pivot. If we apply a force of 5 newtons, it is going to turn like this. Okay, we can see that. So if we have a force of 5 newtons 6 meters away from the pivot, okay, that's going to produce a moment of 30 newton meters clockwise as we're turning it in this direction, and that is clockwise. Okay, so now that we've got the basics down, let's look at forces at an angle. Okay, so there are 2 ways we can go about looking at forces at an angle. There's the one that we often find in a textbook, but there's also the squash move away technique that I learned from my teacher that you might find useful. So, see which one works out for you. Me personally, I think that the squash move away method, I think this one proves to be easier to use once you get used to it, and it requires less diagramming. But as we said, to each their own. So let's say we have a 5 Newton force acting at an angle of 30 degrees from the pivot, and it's at a distance from 6 meters. Okay, so first thing we can do is we can resolve the distance. Okay, this is what they're going to teach you in the textbook. So if we know that the distance has to be perpendicular, that means that the 5 newtons that's acting here has to be perpendicular to this imaginary line that we've constructed here. So here, there's going to be a right angle. Okay, so if that's a right angle, that means that this is a triangle. So if you have an angle of 30 degrees, this will be the opposite, and this will be the hypotenuse. So we'll use sine 30 times by 6, and sine 30 is a half, so that'll just be 3 meters. Now, if we know the perpendicular distance is 3 meters, and that this is 5 meters, we can do 3 times 5, which gives us 15 Newton meters, and that's going to be going clockwise. Okay, let's get our diagram back up, and we can see that yes, indeed, it turns clockwise. Okay, now there's another way we can do this, which is resolving for the force. Okay, so if we imagine a force, this line essentially goes on forever and ever here. That's what we assume. Okay, so we can actually extend this line back here because it just goes on in this direction forever. Okay, that's what we assume when we do forces like these. So this is going to be 5 newtons here, right? Okay, now if we resolve for forces, this is something that if you do physics, you might know how to do this. If you don't, we can just do it quickly here. So resolving forces, we can do it. We can resolve a diagonal force into a vertical and a horizontal component. So here, that's our horizontal component. There, that's our vertical component. Okay, so if we know that this is 90 degrees, and that as a straight line, that's just going to be 180 degrees, we know that this is 60 degrees, because 60 plus 30 plus 90, 180. So that's also going to be 30 degrees. Now, if that's 5 newtons, that's 30 degrees, that's 60 degrees, well, we can resolve what the upwards force is using our triangle here. Okay, because the vertical force and the horizontal force are at right angles. Okay, so if we take 30 as our angle that we're using, so it's going to be So we take 30 as the angle we're going to be using here. So it's going to be, and this is the one we want to work out. So that's going to be the opposite. So it's going to be sine 30 times 5, which is 2.5, because sine 30 is a half. 2.5 times by 6, because remember, if we have this vertical force as 2.5 newtons, right, it's now at right angles and is perpendicular to the pivot. So we can just do 2.5 times 6, which is 15 Newton meters. Okay? Now, both ways we get the same answer. This way is going to be a little quicker to use, and I'm going to show you a method that makes it quicker. But this is generally the one, but resolving for distance is usually the one textbooks want you to use. Okay? And we notice that the 15 Newton meters that we got in both answers is less than the 30 Newton meters we got in the first one. Because if we think about it, right, if we take our diagram here, we've got the 5 newtons here, we've got, say, let's just say, for argument's sake, this is just 4 newtons and this is 3 newtons, right? Because, and we know that the force can go on forever and ever, right? So what we can actually do is we can actually put this all the way over here, right? So we can resolve it like that as well, because remember, it goes on and on. So what I could do is, just like I've got here, I could resolve it like that. Okay, that's a bit bad, but yeah, we could resolve it like that as well. Okay, now what we'll notice is that if we just put it here again, okay, so if we were to resolve it, okay, I shouldn't have done the first one, but if we resolve it like this, okay, up and across like that, so up and across, well, we know, what do we know? We know is that the 4 newtons, that's going in the same, that's going into the pivot. There's no parallel, there's no perpendicular distance, and the line of action is in accordance with the pivot, right? And look what happens when I do something to the pivot like this. Nothing happens. It just stays still. So this 4 newtons, we can just ignore this, right? And we take, and then we'd only take the 3 newtons into consideration. So what we end up with is less force when we do it at an angle than if we did it perpendicular, right? So when we apply a force perpendicular to a rigid body, that's the way we're going to get the maximum moment. And when we start sort of angling it away, we get a lower and lower moment until we reach 0, because 5 newtons just doing that, it's not going to do anything, it's not going to turn. Okay, so now we've looked at forces at an angle by resolving the distance, by resolving the angle, resolving the force. Now we're going to look at squash, move away, and this one's going to take a bit of thinking, so let's get into it. Okay, so we've got the pivot here, which is 6 meters away. We've got force of 5 newtons, which is 53.1 degrees from 6 meters. And, well, okay, we know what the forces are right here. Okay, but let's try and figure out what the moment here is using the squash move away method. Right, so what I could do is I could draw a triangle, and this is just to show you how the method works. Okay, so again, we have a force of 5 newtons, we have an angle of 36.9 degrees, we have 53.1 degrees, and now we need to figure out this vertical component here that's pushing it like this. Okay, so what we could do is we could do cos, so we take this as the hypotenuse, we take this as the adjacent, so we're going to do cos 36.9 times by 5. Okay, and let's get our calculator out. So cos 36.9 times by 5, that's about 4 newtons. Okay, so that's 4 newtons upwards, just like that. Okay, now, what we can notice is that if we take our 5 newtons here, and we take our 4 newtons here, right, we don't really care about this 3 newtons because it's just acting in the direction of the pivot, right? It's not going to do anything. We can just throw this away. So if we have our 4 newtons, we have our 5 newtons. If we say that we squash, okay, because we're taking 36.9 degrees. So basically, if you have something like this and you squash the angle, okay, you do 5 times by cos 36.9, which gives you the angle of 4 newtons. Okay, similarly, if you wanted to work out this angle, which usually you don't, okay, so if we model it like this, we can also sort of put the 3 newtons here, right? Because they're both acting in the same direction. So, and we squash it, we can do, we move away, we'll do sine 5 times sine 53.1 times 5, sorry. Okay, and sine 36.9 times by 5. And what does that give us? So sine 36.9 times 5, which gives us an answer around about 3 newtons. Okay, so this is a method we can use when we're trying to, when we don't want to draw a diagram. So this time, if we just imagine it sort of like this, that's the pivot, okay? This is 5 newtons of force, okay? So we're going to squash the angle, which means we're going to do cos of this angle, okay? Sorry, we're doing cos of, because we're squashing this angle here, right? We're squashing it, we're going to do cos, and that's the way we can figure out this one here without drawing any diagrams at all, which may prove more useful to you. Again, it's really up to you and what you prefer. The exam, usually the textbooks want in the textbook solutions they resolve distances, but here we're resolving forces. And yeah, that try out a few questions and see which one works out for you. I hope you enjoyed watching. If you have any questions, drop them in the comments. If you have any topics you would like me to go over, don't be afraid to ask. And that's all for today. Thank you for watching. Goodbye.